What they do not give you, you go ahead and just put like a little X there. Don't scribble it all up because you may need that variable. Okay? I'm going to go ahead and pull out my chart like I've been doing, and I still like to use this chart. First step, was displacement or distance ever discussed or used? Yes, it was. It's my unknown. Was t ever discussed or used? No. My chart tells me to go here. It's guiding me in this direction. Now, one does to make sure that there's always exceptions to the rules, and you never know what's going to happen. But at this moment, this is what they told me to do. So I'm going to go ahead and write that down for me. A equals VF squared minus VI squared over 2D. And that's the equation it told me to use. So at least I have a starting point. Alrighty. Now, I'm actually looking for the displacement. But before I go further, let's see if this is the right equation. Let's find out. Do I have the A? Check. VF? Check. VI? Check. 2, it's a given. D, my unknown. Now, when you have an equation where your variables is within the equation, this equation itself can be put into the triangle, and I love to do that. You can, number one, algebraically solve for this, right? This has to go to the top. But I don't want to do that. So I'm going to go ahead and plug this sucker into the triangle. Cover up the equal part, and then plug everything else in. This is at the top of the division. So VF squared minus VI squared. 2D needs to go anywhere at the bottom. And then move your hand. What's left over? The A. I'm going to circle what I'm looking for. I'm looking for the D, but that 2 is attached to it, so they come together as a group. Write that down. 2D equals, because now this is my new equation. If you need to, cover that up. What's my equation now? VF squared minus VI squared over A. This is no longer my equation. This is my new equation. So did I find my correct equation? Yes, I did. And it's arranged the correct way that I need it to be arranged. Let's go ahead and plug it in. 2D equals, what was VF? 0 squared minus 23.61 squared over negative 1.3. Let's go ahead and do the math. 0 squared, subtract that, which is 0. Let's go ahead and cancel this out. Again, algebra skills. You cannot cancel out that negative or that subtraction. This subtraction is going to go along with this guy. So keep it. You're only scratching out this number. That's 0. But what happens with a negative divided by a negative? Oh man. You're going to have a nice number here. Let's get 23.61 and let's square it. Hopefully you get a number something like 557.43. So 2D equals negative 557.43 over negative 1.3. Okay. Let's do this math. You're going to do the division over here. What happens when you divide two negatives? You get a positive. So is it going to end up at 428.79? Again, I'm trying to do step by step so you can see it. 2D equals 428.79. I'm not done. I still need to get the distance or displacement on its own. Divide by 2, cancel. Divide by 2. D equals 214.40 meters along the road. Okay? Now don't forget, we got to have a direction when it's a vector quantity. Direction right here is needed for vectors. Okay? And if you're going north, that's a positive value. If you go east, that's going to be a positive. If you go south, that's a negative. And west is a negative. Okay? We're not done yet. Let's go ahead and keep practicing. Okay? Because sometimes we still need to practice. This is a special situation. On Friday, right now it's Thursday night. So tomorrow, Friday, when we have our meeting, I'm just going to go over this fairly quickly. It's here as a practice problem for you to practice. It's you're going to need to, I guess you could say, memorize this part because it's not on your formula chart. Okay? One more time. This is not on your formula chart. There's about 4 equations out of the whole school year that are not on your formula chart. This is one of them. Okay? So let's go ahead and let's look at this equation. It says here that a car accelerates through, a car accelerates through a 85-meter stretch of road distance, reaching the velocity of, well, at this moment I'm not too sure what velocity it is, but it does say that reaching. So if you're going to reach, then that means that you're going to end up over there. Okay? That's what it sounds like. Reaching. Sometimes you have to really read the word problem so that way you can figure out what they gave you. If it took 6.3 seconds t, what was the car's acceleration? Question mark A. Okay? Again, one more time. What is our steps? Number 1, we are going to write down all 5 variables and find the equation. Let's do that. VI, VF, D, T, A. VI, I don't know it. The car was on the road and it reached a certain velocity. So it reached it at 27 meters per second. The distance was 85 meters. The T was 6.3 seconds. The acceleration is my unknown. So is VI 0? Did it start off at 0 and then it reached it? Did it say that it started from rest and it reached it? Okay? Did it say that? Well, no, it did not say that. So what we're going to do, I'm just going to come over here and I'm going to put right here, do not assume anything in physics. Right? I know I mentioned that in one of our teams meetings. I'm going to say it again. There's a couple of things in physics so far that I found that we can pretty much kinda assume. Number 1, when we're reading a word problem, if they do not mention that we're on a different galaxy, that we took Miss Frizzle's bus and we left and went to the moon, they didn't say anything like that, then we are going to assume that we're on Earth. That's one of the assumptions out of all these years I've been teaching and working and doing physics. That's one of them that I've came to the conclusion on. But again, though, it's just an assumption, not always a guarantee. The other assumption, remember what I talked about. We have this thing called entropy, one of the laws of thermodynamics. And entropy states that things constantly go towards a disorder, okay? Meaning that it's always normally going to move forward and go towards a disorder. So we can pretty much assume that when we're talking about graphs, my objects, if it doesn't say in words or we can't really see it on the graph picture, that it's moving away from the origin. Okay, just like we're continuously aging, we're moving away from our origin of being brand new babies. Okay, so that's another assumption that so far I've been able to see in physics. But not everything, we can't assume that's zero. So here's what I'm going to do. What do I do when I don't have any information on it? I put an X on it. That's all I can do. Okay, now let's do this. What do we do after we write all of our variables? We go to our handy dandy chart, which is like magic because this is pretty awesome. And we ask ourselves, was displacement or distance ever used or discussed? Yes, it was. Now we go to question 2. Was t ever used or discussed? Yes. It gave me this equation to use. So this equation is what I'm going to write down over here. D equals VI multiply it by t plus 1/2 a t squared. There goes my equation. Now remember what I've been doing this whole time. If you do steps like I do, then you should be completely good and on the right track. I wrote down my variables. I went to my chart. I followed my chart and I wrote down the equation they told me. Now the next step before I do anything is I go back and I check the equation and I check it with my variables to see, just to double check to make sure. Do I have the D? Yes. Do I have a VI? No. That's okay. Let's keep going. Do I have a T? Yes. Do I have the 1/2? A given. Do I have the A? That's my unknown. And I do have the T. It looks like this variable and this variable I don't have. Why would my chart guide me here if I don't have enough information to answer it? Okay? This is a special situation. So in a special situation like this, let me come over here and like star this, because hint, hint, we need to know this information. So this special information that we must know and need to know, here it is. Let me write it out for you. Well, when VI and A are both not given, look, not given, not given, I don't have them. You're still going to use this equation, but Miss Munson, that doesn't make sense. How am I going to use this equation if I'm missing both those variables? I can miss one of them, but I can't be missing the other one too. But here's the trick. Oops, but we're going to change the VI to a VF. And why do I all over the place with my spelling today? Normally I'm bad, but this is really bad. And change the positive or the addition to a subtraction. What? Watch this. We're still going to use our handy dandy flow chart, and we're going to follow the guidance that it gives us. Okay? But instead, we're going to change the VI to a VF, and we're going to change the addition to a subtraction. So watch this over here. We're going to say D equals VF parentheses T minus 1/2 AT squared. X this out. Here's my new equation. But remember what I told you, when we write down our equation, let's go ahead and double check with our variables that it's going to work out. D, check. VF, check. T, check. 1/2, a given, check. A, question mark. T, check. Look at that. Pretty darn awesome. So let's go ahead and fill in the blanks here. 85 equals 27 parentheses 6.3 minus, change that to a 0.5, do not keep a fraction, A parentheses 6.3, do not forget to square that T. Okay, let me go ahead and keep going with this with you just to make sure. I'm not sure how your algebra skills are, but I'm sure they're probably awesome and amazing like you. First step is I'm going to go ahead and square this. Please excuse my dear Aunt Sally. So we want to please use the parentheses right here with this exponent. So this becomes a 39.69. Okay, let me go ahead and multiply those two together. When I do that, this becomes 170.1. So let me go ahead. I'm going to move this car out of the way with light out so you can see I like to write my steps out. 85 equals 170.1 minus 39.69, multiply it by 0.5, comes out to a 19.85A. But remember what I told you, don't trust any of the teachers. You always go back and do your math just to double check. Okay? So let's go ahead and keep going. What would be our next step? Our next step is, yes, we need to get A by itself, but let's get this business out of the way so we can quickly get over here to the A. This is a positive 170.1. So let's do the opposite of a positive and let's do a negative. 170.1. That cancels. Minus 170.1. I end up with a negative 85.1 equals a negative 19 point, or subtract 0.85A. Let's go ahead and divide, and I'm going to go ahead and clear this car out of the way a little bit more so I can do my work. I use a lot of whiteout every school year. There. Okay, I feel better now. I've got to get A by itself. So if I divide this side by a negative 19.85, that cancels. Divide this side by a negative 19.85. What was my car doing? My car was accelerating, and it reached. If it reached a certain velocity, that means that it did what? Speed up or slow down? It speed up. Before I answer, what should my answer be for acceleration? It should be a, what kind of value? Positive value. So let's see. A negative divided by a negative equals a positive. Like, this is coming out awesome. This is why I love math. Math is never wrong. A equals 4.29 meters per second squared. Wait a minute, write your direction. They gave it to you over here, east. Now I'm done, and look at that. There goes another practice problem for us, and it gave us this little, we got to see this little weird thing on the side. We were able to solve for a variable that was in the middle, smack dab middle of the equation using our algebra skills. I'm telling you, this is pretty darn awesome. Let's turn the page. We're almost done with this extra practice. Okay, again, this is only extra practice, not mandatory. So when we get to this last page over here, let me try to just kind of set you up and let you do the rest a little bit, okay? You need to practice. A car crashes, a police cruiser is on patrol, moving at 14.72 meters per second west. When it receives a notice of an emergency, it quickly accelerates to 26.1 meters per second. That means that it's sped up. So that means that my answer should be a positive acceleration number. West. Over 73 meters. Determine the acceleration of this police car. What am I looking for? A. My initial velocity, VI, is over here. My final velocity, VF, is 26.1. What is the distance that it traveled? 73 meters. Step number 1 is always going to be going to write your stuff out. VI, VF, T, D, A. VI is 14.72. VF is 26.1. T was never discussed. D is 73. A is my question mark unknown. Before I go any further, I'm going to get my handy dandy flow chart and I'm going to ask myself, was distance or displacement ever used? Yes. Was T ever discussed? No. This is the equation I'm going to use that they guided me to. A equals VF squared minus VI squared over 2D. Remember what I told you. Once we get that equation down, let's don't take it on its word for its word. We need to kind of go back and double check. All right, what am I looking for? A. If I'm looking for A, then all my other variables better be there. VF, check. VI, check. 2, a given, check. D, check. That is the equation I'm going to use. Please practice this equation. Do not forget to square those numbers, okay? Let's keep going. A fire truck is also on its way to that same emergency. The fire truck accelerates, okay, at 0.75 meters per second squared. A. It's a positive number, so that means it's speeding up. For 37 seconds. T. From rest. VI is 0. How far, question mark D, did it travel in that time period? Step number 1, write down your variables. VI, VF, T, D, A. VI is 0. VF, never given. T, 37. D, question. A, 0.75. Not a problem. Step number 2. Get your handy dandy chart. Was displacement ever used or distance? That's my unknown, so yes. Was T ever discussed? Yes. This is the equation they would like you to use. Do you see how continuously practice is going to make you get better at this? Here's my equation. D equals VI parentheses T plus 1/2 AT squared. There it is. Let's keep going with this. Next step. Even though this is an awesome chart, we want to make sure that it did not steer us in the wrong direction. Okay? What am I looking for? I'm looking for this, D. Okay? So everything else better be here. VI, 0. Check. T, check. 1/2 is a given. Check. A, check. T, check. Could I use this equation? Absolutely. Fill in all the variables. Answer for the displacement. Don't forget it's going to travel east. And we are done with the notes here that we're practicing with. They are not for a grade. They're not for extra credit either. They're for your own benefit. So that means you do not have to watch it or do them at all. It's just here to help you. If there's any questions, please let me know if there's anything else I can help you with. Other than that, you have a great weekend. Bye-bye.